do best is they can what's called transfer learning. So you can actually train a model, like you can have a giant model that's trained on classification, right? And you can have a specific task that has to do like with the office, with an office space. You can take the classification model that it has this really large one, and you can actually transfer its how it learned, like the certain categories it's learned for this. You can also do this across domains, so you can actually transfer audio to video. I will show that hopefully with an audio like can let's see here. Let me just, I gotta change one thing. Sorry, 1 second. Okay, so OpenAI created the model, GPT, and they do talk a lot about the quote unquote general intelligence. Like they want to create, every model that they try to create comes from the idea of a general intelligence, which is like what James was discussing with NLP, the difference between natural language processing and like what we're doing now, generative processing, because natural language is top down, and it starts with the ones that you would basically work for. Obviously, you have like how with the length that it will produce, and it only does 248 characters, okay, which is a lot, and that includes your input because the input becomes part of the thing. So that would be like a whole thing. I'll tell you that. Your temperature controls your randomness. Okay, so you know you'll have more and more repetition and similarity and plagiarism if you're down here in the zeros. Usually people have this around 7, around 0.7. I've seen people go up to 98. That would be like, but it gets kind of weird at that point. It starts to produce like nonsense, and a lot of it gets caught on a phrase, and we'll just keep going. Your top P, or sometimes it's your K, controls the diversity. So it means that like if you're basically truncating the weights, what it knows. So you can constrain its you can constrain its context. It'll have some kind of generative context, but you constrain like the kinds of tangents that it will go on, right? And frequency penalty obviously is every time a word is repeated, it's going to get penalized. So that's going to make it it's going to make it you can like basically bias it, right, not to repeat words. And then you also get a penalty though for introducing new words, presence penalty, so that way you keep a consistency. So you can change these two models basically to keep change the relationship. You can do the best of, because these things work, they compute parallel computing, whatever, they work at the same exact time. So they take a long time sometimes, but if you run them in parallel, they take the same amount of time, but you'll have like 16 versions. Usually this is like 5 or 16, but like, you know, I keep the top one will be the best, right? Stop sequence. The way these things are trained, sometimes there's one thing in the way that they trained it, is that inside of the text, if they have these kinds of start and end variables, that when it finds this in the text, then it will know that the phrasing is stopped. So for instance, if I have a script and I'm trying to teach and I want the script to like learn dialogue, so I'm going to like specifically channel out dialogue and put start and end at the end of dialogue, so it'll learn the relationship for dialogue. Or I would put a different tag. I would say the dialogue tag versus a scene description tag. And then if I put start text in the prompt, then it will generate something knowing that, or dialogue text, it'll generate something in that. That's what the stop sequences are. Okay, injection just means adding into the prompt. And if you want to show the probabilities, you can see the full spectrum. But here, this is what I was talking about. Like, this is all the exact same model, but the way that they construct the prompt, what you input, is what generates the model. So there's a whole thing called prompt engineering that people do. And that's like, either you just go brute force and you just do everything you want to do, or you create software that can like run through a bunch of different prompts. They've figured these ones out by just like trial and error and a really large community. That's why we have all these different authors on this because of the wide collaboration. Now it's on a trained model. The trained model is, the way he was explaining it, is this very large, just like, it's just given a bunch of text and the model trains generically on it and finds its own relationships. And then we humans or engineers go back to it and start to do what I'm doing on this interface and start to like construct prompts to figure out what it knows. So at one time, it has fragments of things, like a lot of news articles. So if you gave it like things that sound like it's a news article, it will do really well. If you give it a thing that sounds like a Reddit post, it'll do really well. Like, you can even read, there are resources of like the top websites that it trained from, like people have actually recreated it with the same like kind of data. So you can like kind of, there's that. It knows all of this, and like humans, we get a thing and we try to interpret and respond to it, right? And that's what this is trying to do. Because that's general intelligence is conceptual, like intelligence. It's like knowing the concept or the abstraction of something, being able to act on it. Whereas like artificial intelligence proper is task based, right? It's not, it doesn't know the concept. It doesn't have a concept of the thing. It just knows the steps. Now the problem theoretically is the concept is not, if it's a pure thought or not, but that's another story. The second thing is you can fine tune the model. So like I can provide you all I can provide you all like a Google Colab. I haven't sent it, but I will, where you can just have a text file of whatever you want. Recently I did one on Twilight Zone, of all the Twilight Zone introductions that Rod Stewart did. Robert, what is his name? But anyways, but that he did, he wrote them he was very detailed in his book when he wrote them. And I basically can produce those like out of nowhere, and I just fed it those texts. So I'll go over that second half of class, how to do that. But that way, what you do is you take this general model, which has all of these layers that control 175 billion parameters, and there is a top layer. And that top layer is like the most, I would say it's like the most understandable to us, because if they integrate up a model, like the context gets more and more abstract, right? And more like becomes a concept. It goes from like pieces and parts and becomes somewhat of like a whole at the top. And there you can actually reset the weights by feeding it in the text file, training it for a certain amount of time. And that way you can train the prompt to always look for a specific thing. Does that make sense? Now, when you're doing a prompt, you can't, when you're doing a prompt, like from where I am on this up here, you you can't, you have to understand that like it can't take a whole text because it only has 248 characters. So, and that input becomes the beginning of the generation. That's how the generation starts. It uses that. So you have to be cautious of like how many words you put in.